Look at this process. It takes years to master shaping pottery or stitching leather by hand. But right now, the artisans behind these crafts are trapped in a geographic bubble. Their entire income depends on whoever happens to walk past their physical workspace. Building a sustainable business on localized foot traffic and word of mouth creates a hard economic ceiling. When a customer base is restricted to a single neighborhood, revenue plateaus early, and scaling the operation is mathematically impossible. This diagram represents HunarHub. It's a centralized digital marketplace engineered to solve this exact bottleneck. It takes completely fragmented, isolated offline vendors and aggregates them into an interconnected hub-and-spoke model. By acting as a digital proxy, the platform translates physical artisanal skills into a searchable online inventory. Customers can instantly discover local talent, and micro-entrepreneurs gain a structured pipeline to accept service requests and sell handmade products. Formalizing these informal community interactions into structured, queryable data is the baseline prerequisite. It is the only way to scale local economic sustainability beyond the immediate physical block. Building this system presents a unique architectural challenge. We have to bridge the rigid, structured requirements of modern e-commerce with the highly variable workflows of local micro-entrepreneurs. On one side, the customer needs a frictionless standard experience. They require transparent pricing, structured service discovery, and the ability to filter results accurately by geographic location and skill type. On the flip side, the entrepreneur requires a severely low-friction dashboard. They need a simple interface to manage their availability, accept incoming orders, and track basic earnings without getting bogged down in complex inventory management. This creates a dual-sided marketplace. The architecture must run two parallel, entirely distinct user interfaces that constantly sync back to a single source of truth. To make this work for vendors with limited digital literacy and entry-level smartphones, the system design must be driven entirely by aggressive hardware constraints. Feature bloat is the enemy. If the application is heavy or overly complex, it will be ignored. Prioritizing a constraint-driven architecture prevents platform abandonment, ensuring we successfully deploy software to users who possess high physical craft skills but low digital literacy. Engineering a stable minimum viable product requires strict scope containment. We have to ruthlessly define what the platform will not do. This comparative matrix maps the explicit mandates dictated by the product requirements document. We have our standard in-scope features on the left, but the out-of-scope parameters on the right are where the actual engineering strategy takes shape. Native mobile applications are completely eliminated from the roadmap. Bypassing the App Store removes a massive point of friction. Users on low storage devices simply access a responsive web interface. Next, we look at fulfillment. Both international shipping and automated logistics management are stripped out. By relying exclusively on localized service fulfillment, we keep complex routing variables entirely decoupled from the digital platform. Finally, advanced AI recommendations are rejected to preserve absolute back-end simplicity. Enforcing these rigid exclusions accelerates deployment time while protecting the entire system from cascading edge case failures. We translate offline skills into standardized database tables. This entity relationship diagram maps the connections. Actors are split into users and micro-entrepreneurs tables, storing names and locations. Disciplines map into categories and skills tables, linking cobblers and tailors to entrepreneur profiles. Isolating categorical data this way allows the front end to execute scalable, high-speed search queries. When a customer searches for a specific skill type or price range, the database doesn't parse text descriptions. It simply references the assigned category ID. Then the transactional entities appear: the products, service requests, and orders tables. These create the relational pathways connecting the customer directly to the vendor. The architecture treats these transactions differently. A static product purchase triggers a standard checkout flow, but an asynchronous service request requires a persistent ledger, tracking the back-and-forth communication constantly until the job is completed. A strictly enforced entity relationship diagram is the only way to process highly variable, unstructured offline labor at scale. Tracing a transaction, a search query moves from user to categories. The system returns a local active profile. Submitting a service request generates a pending request node. The vendor reviews and accepts. The node turns green, locking the connection. Standardizing the request lifecycle into binary state changes entirely eliminates the ambiguity, pricing opacity, and miscommunication inherent to traditional offline bartering. Supporting this flow requires specific technical mandates for speed and concurrent bookings. This three-tiered architecture map shows the environment. The top layer populates with React.js or Next.js to construct a responsive front-end interface. Utilizing a robust mobile-first web framework effectively compensates for the strategic lack of native mobile applications, delivering app-like performance strictly through the browser. Data inputs from the UI layer are then piped down into the backend server architecture. This middleware layer is built utilizing Node.js and Express.js to construct a dedicated REST API. Handling requests without crashing requires a decoupled API architecture where each request functions independently. Finally, the middleware pipes drop down into the database layer, presenting a choice in data management. On the left, MongoDB offers flexible schema benefits, ideal for accommodating widely varied, unstructured artisan product listings. On the right, Postgres provides the relational strictness necessary for maintaining bulletproof financial order ledgers. This highly decoupled architecture entirely insulates the core database logic from the erratic network conditions and latency spikes common to the mobile front-end users. To measure the viability of this MVP architecture, we use a dashboard tracking core metrics. The first dial tracks registered entrepreneurs versus active users, immediately flagging any UI onboarding friction. The second dial expands to track service conversion rates, the primary indicator of overall platform health. High conversion rates mathematically validate the simplicity of the front end. It proves that users are successfully navigating from discovery to a finalized booking without dropping off. But actively tracking average entrepreneur earnings remains the ultimate metric. A technical platform is only successful if it drives measurable, sustained community economic growth. The foundational, constraint-heavy architecture of this initial iteration acts as a necessary baseline. It proves the model works under the strictest possible conditions. From that stable baseline, we establish platform extensibility. Future modules like payment gateways and digital wallets map onto the existing logic. External logistics APIs seamlessly plug into the Node.js middleware without rewriting the core application. Mastering digital inclusion requires deploying systems that deliberately restrict initial functionality. By doing so, we ensure that technical complexity only grows in lockstep with the user's increasing digital literacy.